This screencast is to correct the problems that I got wrong on the test. And for this problem, the only thing that I got wrong is that I calculated the angle of the vector that was already in component form, which I wasn't supposed to do. So I simply erased the angle that I calculated, and everything else stays the same. And I'm not going to go through it since you already went through it. So that's that one. And then next one would be this one, which I redid here. The mistake I made the first time was that I came up with, in the y direction, the force of the push being F cosine of theta, but it was actually supposed to be the force of the push in the y direction was F sine of theta, and that's where I made my mistake. So we'll go through it over here. Some of the forces in the y direction are normal force minus mg cosine of theta minus the force sine of theta equals ma, which equals 0 because there's no acceleration in the y direction. And the sum of the forces in the x direction would equal f cosine of theta minus mg sine of theta equals ma. And then to find the force you would need to have the block stay still, the acceleration would be 0. So we set acceleration equal to 0, and we get this equation. And we just I just solve this equation, and I end up getting F equals mg tangent of theta, which I solve to get the force is 49.29 newtons to keep the block from moving, or the crate. And then what would happen if you change the magnitude of the pushing force to 100 newtons? We use this acceleration equation that we found up here. Acceleration equals that, and then we plug in 100 for the force and solve that, and we get the crate would accelerate up the ramp at 4.53 meters per second squared.